It's time for Security Now. Steve Gibson is here. We have an update on that Microsoft Windows driver blocklist flaw, I guess you'd call it. 3 years they haven't updated it. Finally, they have, and how you can do it manually anytime you want. SQLite, S-Q-L-I-T-E, has a big security flaw. It's everywhere. We got to fix this one. And then some thoughts. After 20 years in Britain's GCHQ, what we've learned about security. It's all coming up next on Security Now.
Podcasts you love.
From people you trust.
This is TWiT.
This is Security Now with Steve Gibson, episode 895, recorded Tuesday, November 1st, 2022, after 20 years in GCHQ. Security Now is brought to you by NordLayer. NordLayer is a secure network access solution for your business. Join over 6,000 plus fully protected organizations at nordlayer.com/twit and get your first month free when purchasing an annual subscription. And by Collide. Collide is endpoint security that uses the most powerful untapped resource in IT, end users. Visit collide.com/security now to learn more and activate a free 14-day trial today. No credit card required. And by IT Pro TV. If you're looking to break into the world of IT, or if your IT team needs to level up, get the introduction you need with IT Pro TV. Check out an IT Pro TV business plan by visiting itpro.tv/security now today. It's time for Security Now, the show we cover your safety at home and abroad, mostly on the internet, generally with computers. Mr. Steve Gibson is the king of security. Hi, Steve.
Yo, Leo.
Good to see
Great
you.
to be with you for the first day of November.
Can you believe it? November 2022. Amazing.
Wow, we're going to have a little rain tonight. I heard you are in the rain right now.
It's actually cleared up, and we sent it down south just for you.
Thank you. Well, we could use all the moisture we can get down here.
Yeah, no kidding. Oy.
Thank you very much.
Yeah.
Okay, so there was an interesting array of news, but nothing really grabbed me until I was catching up on my Twitter feed, and somebody, probably one of our listeners over in the UK, posted a link to sort of a memoir of, actually it was like the goodbye posting posted by the guy who's been running the UK's cybersecurity for the last decade and has been at GCHQ for the last 2 decades, for 20 years. And so he had a lot of interesting things to say. It won't shock anybody, because if you have been listening to this podcast, interestingly enough, these are pretty much the themes that keep echoing through, the microphone here, but still interesting to get a perspective from somebody completely outside of this podcast. So this episode 895 is titled After 20 Years in GCHQ. And I went back and forth about whether it should be at GCHQ or in GCHQ, but I just thought, well, okay, we'll go with in. But we're going to revisit first the Windows driver block list, which has received its long-needed, after 3 years, update.
Oh, man.
I know. And actually some weird official policy statement about this. Like, what? Anyway, also, Microsoft has developed their own definition of a CVE, which seems determined not to have as many, just by changing the definition.
Yeah, of course.
Why not?
Why not?
We also will note that sometime today, actually it did already happen, the OpenSSL project will be releasing an update for what was originally believed to be an ultra-critical flaw in OpenSSL version 3, not the earlier versions. But now they've sort of, I guess, mitigated the criticality due to the fact that it's not so easy to have it happen. Anyway, so we're gonna mention that. Also, we're gonna look at a remote code execution flaw in Windows TCP/IP stack. We've got a ubiquitous problem in the past 22 years of the widely used SQLite library and a surprising percentage of malicious proofs of concepts found in GitHub. Passkeys is to get another supporter, and the first part of a professional tutorial explaining, get this, how to exploit the Chrome browser has been released.
Finally, a tutorial. It's just always needed that. That's good.
That's what we need. But the best news is it's not on YouTube. I thought, oh my God, am I going to have to watch another YouTube video? No. This is just, you could scroll. Thank goodness.
We must be old timers because I have the same exact reaction. It's like, please.
Yeah, every time I'm looking for something, it's, you can find out about this by watching this YouTube
Hey,
video.
guys,
it's like, no,
smash the subscribe button.
Just tell me.
Yeah,
please just print it.
There's an interesting incentive at play I just found out about because YouTube won't put an ad in unless you're a certain length. So they always have to get to a certain point.
Oh.
And that's why they pad these things. You get the. In other words,
it doesn't generate money for the person posting it until it's long enough to have YouTube do an insert.
So then they pad it. So, and for some reason they decided, I guess, well, we won't, maybe because we want to keep people watching, we won't give you anything we're going to talk about until about 10 minutes in. There's all this prologue. It's like, please, I don't.
Yeah.
Anyway, we're old.
The good news is this tutorial is written. And
Yay.
You can scroll.
Oh.
Okay, then after a bunch of listener feedback and a quick SpinRite update, we're going to look at the goodbye posting of the UK's head of cybersecurity after his 20 years. So,
interesting.
I think a neat podcast for our listeners. And, of course, we've got the picture of the week, which is kind of fun because you wonder why they put a high security gate on this entrance or exit or whatever the hell it is.
I really the best part of this is the subtitle. So I'll leave that for you in just a little bit. But first, a word from our sponsor, NordLayer. NordLayer safeguards your company's network and data. Well, that doesn't tell you much, but that's a start. With a surge of ransomware attacks and employees choosing to work remotely, business networks have become much more vulnerable than ever. So how does NordLayer protect you? It secures and protects remote workforces and protects business data. It can even help you ensure security compliance. It's easy to start. NordLayer just takes 10 minutes to onboard your entire business or create a completely secure network. 10 minutes away from a completely secure network. You can easily add new members, create teams and private gateways, even do things like IP allow listing, site-to-site connection, network segmentation, setting up secure network access. You want to get 1 month free? Take a look. You might want to go to nordlayer.com/twit, NordLayer.com/twit. NordLayer is also easy to combine as it's completely hardware-free. It's compatible with all major operating systems, so you can implement security features across all teams, no matter what they're using. You can add things like two-factor authentication, single sign-on, biometrics, threat blocks, smart remote access. NordLayer. Easy to scale. Choose a plan that fits your business requirements today, grows with you tomorrow. You could choose your rate of growth. You'll even have everything centrally in one place. You could check the server usage, monitor connections to your gateways, view the activity log, the console, and this is great. One NordLayer user agreed. He said, we were looking for an easy way to securely connect our remote workforce to our infrastructure, and this is it. Awesomely quick, friendly, and efficient support. Got us up and running in no time. Another said, simple to install and operate, no funny business, and so fast our teams don't even notice they're using it. Look, I know we talk a lot about, and most modern businesses are probably already adopting things like SASE and Zero Trust and hybrid work security. Well, you get all of that and more with NordLayer. Bottom line, don't leave your business vulnerable. Try NordLayer today. Join more than 6,000 plus fully protected organizations. NordLayer. If you want to secure your business network, go to nordlayer.com/twit. Get that first month free when you purchase an annual subscription. NordLayer.com/twit. Give it a try. NordLayer. NordLayer.com/twit. patreon.com/twit. We welcome them to Security Now and the Security Now podcast.
Yeah, cool.
Now, the picture of the week.
Okay, so there's a staircase, sort of like, I don't know, like the back of a building or something coming down, where clearly the intent was to prevent people who weren't somehow authorized to gain access to the staircase from the outside. I don't know if there's like a panic bar that you could push to release in order to get out, but you certainly can't get in. And so the staircase has this protection gate, which is closed, very tall, so it would be very difficult for you to, like, you'd have to have two people like to give you a leg up in order to like get to this, just like to scale this and get over it. So, okay. Now, the problem is that if you just go around the corner from this gate, there's the stairs.
Just climb right over the railing.
And there is a low railing, less than half the height of the big gate, which, you know, would be difficult to scale. And the railing has been conveniently created to sort of have like a ladder. So you could even use it to help you climb over it and get you to the stairs.
Well, we don't want to lock you out.
So, right. Now, what was fun about this that you commented on was that somebody who prepared this picture, they, in a big green rectangle, circled the gate, which, you know, is what you're supposed to focus on, and labeled it in scope. And then, because this picture shows both sides of this problem, there's a red box that circles this, like, the simple means of bypassing the gate, which is labeled out of scope.
Not our problem.
Yes. And so then I gave this picture of the week the title, quote, out of scope, unquote, equals somebody else's problem. Meaning, it's, we didn't quite achieve our goal here, but, this is the fact that you can bypass this gate. Well, that's
not my problem.
Not our
man.
problem.
Not my
That's
problem.
right. You said you wanted a gate there, boss, so we gave you a gate. Okay. So, recall our coverage last week of Ars Technica's reporting, which was titled, quote, How a Microsoft Blunder Opened Millions of PCs to Potent Malware Attacks, unquote, and that indeed some follow-up digging revealed that many malware strains had been found to be actively leveraging known vulnerable drivers in what is now called the BYOVD, the Bring Your Own Vulnerable Driver attack. And also recall that Microsoft's minions, even those in elevated positions of authority, were openly rude and hostile to the researchers who were just trying to help, to prompt them and to understand what was going on. And Microsoft said, this is the way we want it. Well, okay, this may be where shining a bright public light can help, since Microsoft has gotten off their butts and finally, after 3 years of neglect, fixed this arguably important issue. Last Thursday, ZDNet carried the news with their headline, Next Windows 10/11 Patch Tuesday. Okay, that means a week from tomorrow. A week from today. Next Tuesday will be Patch Tuesday for November. They said next Windows 10/11 Patch Tuesday fixes Microsoft's botched vulnerable driver blocklist. And the subhead was, Microsoft addresses an issue preventing Windows 10's vulnerable driver blocklist from being updated with new vulnerable drivers. Okay, so here's how ZDNet summarized the situation. They said Microsoft has released a new non-security preview, has released, how like they do the non-security previews the month before. So Microsoft has released a new non-security preview of November's Patch Tuesday update for Windows 10 and Windows 11 22H2. It brings improvements to the taskbar, Microsoft account, and task manager, as well as a fix for a serious Microsoft blunder that left a hole in the Windows 10 vulnerable driver block list. The preview is a non-security update that's available for Windows 10 and Windows 11 22H2. It contains all the changes in the upcoming November Patch Tuesday, except security patches. However, this preview also includes Microsoft's answer to a serious security-related error that the company made with its Windows kernel vulnerable driver blocklist, an optional security hardening capability introduced to Windows 10 version 1809, so like the old one, that's on by default in Windows 11 22H2. Microsoft has explained that the failed updates to the blocklist were due to it, and this weird language, to it only updating for full Windows OS releases. They said, although it's not clear if this means previously installed Windows versus fresh installs, or just that older versions of Windows were stuck on a block list that couldn't be updated. You know, what does it mean? Full Windows OS releases. In a support page detailing, quote, the vulnerable driver block list after the October 2022 preview release, Microsoft states, this October 2022 preview release addresses an issue that only updates the block list for full Windows OS releases. Okay, so does that mean they're changing that or not? We don't know. They said, when you install this release, the block list on older OS versions will be the same as the block list on Windows 11 version 21H2 and later. Okay, so a catch-up. Microsoft had told Ars Technica, writes ZDNet, that it was in fact regularly updating the vulnerable driver list, but that there was a, quote, a gap in synchronization across OS versions. Again, it's no longer possible, apparently, to get Microsoft to actually tell anyone what's going on. You just have to poke it and experiment and figure it out for yourself. So they said so the October 2022 preview release is the promised fix, which should be released broadly in the November 2022 Patch Tuesday, again next week, through Windows Update. Microsoft's release notes for the October Windows 11 22H2 preview update states, it updates the Windows kernel vulnerable driver block list that is in the, and that I'll explain what this means in a second, but they said in the driver SI policy.p7b file. This, and I'll explain that. This update also ensures that the block list is the same across Windows 10 and Windows 11. For more information, see Knowledge Base 5020779. So Microsoft has a page where they talk about recommended driver block rules, which provides a bit more clarity. They say on that page, and I have a link in the show notes, they say, and this is what's weird, okay? The block list, this is official Microsoft.com. Actually, it's learn.microsoft.com. They said, the block list is updated with each new major release of Windows, typically 1 to 2 times per year, but now I guess only 1 time a year because we're not doing 2 times a year major Windows updates, okay? Including most recently with the Windows 11 2022 update released in September 2022. The most current block list is now also available for Windows 10 20H2 and Windows 11 21H2 users as an optional update from Windows Update. Microsoft will occasionally publish future updates through regular Windows servicing, but apparently, like only with each new major release of Windows, which nobody understands. Then they continue saying, customers who always want the most up-to-date driver block list, well, who would want that? They said, can also use Windows Defender Application Control, WDAC, to apply the latest recommended driver block list contained in this article. For your convenience, we provided a download of the most up-to-date vulnerable driver block list, along with instructions to apply it to your computer at the end of this article. Otherwise, you can use the XML provided below to create your own custom WDAC policies. Okay, so they're saying here that the block list is updated with each new major release of Windows, typically 1 to 2 times per year. So it's curious that for some reason, the exploitation of known malicious Windows kernel drivers will apparently be allowed deliberately and by policy for as long as 1 year or during the length of time of the gap between major Windows releases. And this is current policy. Given that BYOVD now has its own abbreviation and that the exploitation of such drivers has unfortunately become popular, it sure would seem that some policy rethinking of this, we're only going to update this list with new major releases of Windows, should be reconsidered. That page also said customers who always want the most up-to-date driver block list can also use Windows Defender Application Control to apply the latest recommended driver block list contained in this article. So I have those instructions and a link to that page in the show notes. But anyone wishing not to wait can easily update their system's driver block list. So to give you a sense for this, it's download the WDAC policy refresh tool, and that's easy to find. It's at aka.ms/refresh policy. Download and extract the vulnerable driver block list binaries. Now that's easy to find too. That's at aka.ms/vulnerable driver block list. Then they said, and that actually gives you a zip with 4 files. They said select either the audit-only version or the enforced version and rename the file to sipolicy.p7b. Copy sipolicy.p7b to, and then your Windows directory /system32 /code integrity. Then they finally said, run the WDAC policy refresh tool you downloaded in step 1 above to activate and refresh all WDAC policies on your computer. So, okay, not difficult to do. For some reason, they don't want to do that for us, except every major Windows release or so. So, anyway.
Is there some way to protect that file? Like, make it be, like...
Presumably,
need root access to it or something. It seems like that'd be kind of just sitting there as a plain text file or something.
Presumably that WDAC policy refresh tool is not something that malware can use. That seems to be the thing you need to take this. All those 4 zip files, they're 95 kbyte files, all dated October 19th, so middle of last month. And you get to choose between audit or enforce in either the server or the workstation flavor. So there's 4 different ones. And hopefully, as you suggest, Microsoft has prevented bad things from happening to these policies or turning them off. But it's just strange to me that why aren't known bad drivers, known malicious drivers, as important to fix every month as others? Is that like everything else? I don't get it. Oh, by the way, when you apply these new policies, you must reboot because they note on their page that just having the policies doesn't prevent things that are already running, like they're not going to get kicked out of Windows. It's only when they're trying to get themselves loaded that the policy looks at it and goes, not so fast, and denies it access. So, and it turns out I can't even turn it on my Windows 10 system because I've got a couple drivers that are not sanctioned. And
now I know why they didn't do this. Not all drivers are sanctioned.
Yes.
And they knew it would cause tech support calls.
Yes.
There you go.
It's like, hey, why can't I use this? I want to turn this on.
Are they weirdo drivers that you have? I mean, what is...
Yeah, there are a couple weirdo drivers. So, yeah, there's one that I actually hacked myself and signed in order to...
What could possibly go wrong?
It was something that Lori needed for one of her in order to distribute software, and it wasn't working, so I hacked it and fixed it.
It's nice to have a handy husband around the house.
And then Windows wouldn't run and it wouldn't load anymore, so I got it signed. And then when it popped up in the list last night, I thought, oh, yeah, that could be a problem.
Yeah, maybe you don't want this block list.
Yeah. Anyway, for everybody else, it's when you try to turn this on, Windows will say, what about this? And I think there were 3 things that were a little sketchy that I had on my computer. So, yeah. Okay.
But folks, he knows what he's doing. Don't try this at home.
No. And it turns out it's kind of tricky to get Microsoft to sign a driver. You've got to, tell them, I'm a good guy. And they said, we don't know. We heard your podcast. So last Tuesday, the Singapore-based security firm Star Labs disclosed a verified and patched vulnerability in Microsoft SharePoint Server 2019, which is current. It was an exploitable post-authentication server-side request forgery, which is not good. Now, what's bizarre is that while this was clearly a flaw that needed fixing, and fix it they did, Microsoft refused to assign a CVE identifier for Star Labs' finding and their work. Now, this didn't escape the notice of some well-known security insiders who took note and tweeted. Kevin Beaumont, who we often quote, who tweets as Gossie the Dog, he quoted the write-up where they noted, they said, they, meaning Star Labs, said the bug had been fixed, but it did not meet the criterion required to get a CVE. And then he put like a weird emoji after that. It's like, what? And so Will Dorman, often quoted on the podcast, he said, replying to Kevin's tweet, he said, a Microsoft CVE, in quotes, is a, quote, security update with associated MSRC write-up, unquote. And he said, using this definition, as opposed to how the rest of the world uses CVE, is what allows them to say, this isn't worth a CVE, and mean it. Wow. So now, just as we have Microsoft's own definition of zero-day, now we have disappearing Microsoft CVEs, courtesy of ignoring the industry's established vulnerability monitoring system by simply not registering discovered problems which require repair and updating. It's not a bug if we don't call it one. And recall that we saw something like this before, where Microsoft was claiming that if no user action was required, then no security event was warranted. We'll just all pretend it never happened, since we'd rather project that image to the world. And on the subject of important things not being swept under the rug, we have, as I noted, what was believed to be an upcoming OpenSSL CRITICAL vulnerability update. Okay, so this was interesting because in order to facilitate the race, which would be between releasing a patch to an important open source system and those who would invariably attempt to take advantage of the patch window before all systems were updated and patched, exactly 1 week ago today, the OpenSSL project gave the industry 1 week of advance notice of a forthcoming, what they called then, highly critical patch to OpenSSL 3.0. The patch release is today, November 1st. Commenting on this back then, Andrew Ayer said, he tweeted, "This will be OpenSSL's first critical vulnerability since 2016. Examples of critical vulnerabilities include, quote, significant disclosure of the contents of server memory, potentially revealing user details. OpenSSL 3.0.7 update to fix critical CVE out next Tuesday does not affect versions before 3.0. Okay, so the vulnerabilities, and we know what they're numbered. They're CVE 2022, 3786, and 3602. They affect version 3.0.x and do not impact OpenSSL 1.1.1 or LibreSSL. That was all that was known as of actually earlier this morning when I checked. Now we know that the patch is out. We know that it is less than critical. It's now considered high, apparently because of some mitigations to how difficult it is to fix. I expect we'll be talking about it next week. Everything should be known. The source code diffs will be made. We'll figure out what they changed. It'll be reverse engineered. Maybe it'll be the case, hopefully, that bad guys won't be able to get much leverage from it. We'll know more next week. And Leo, let's find out more about our sponsors.
Good time to do it, of course.
And then we'll talk about this IP, this remote code execution in the TCP IP stack in Windows.
Oh, man, it's just a never-ending litany of problems and issues and security flaws. That's why almost all your advertisers sell security products. What a surprise. Collide sponsoring this portion of security now. It's an endpoint security solution that I think has it right. They use the most powerful untapped resource in IT, end users. Oh, I know if you're an IT professional, you're going, oh, not my end users. Well, wait a minute, slow down. When you're trying to achieve security goals, whether for a third-party audit or, your own compliance standards, the conventional wisdom, the MDM wisdom is lock it all down, right? Put glue in the USB ports, lock everything you can down. Here's the problem. Old school device management tools like MDMs force disruptive agents onto employees' devices that slow performance, sometimes treat privacy as an afterthought, right? And when you're doing that, you're now suddenly turning your ITs into admins and end users into enemies. And it creates its own security problems because what does the user end up doing? Well, this is too complicated. It's too slow. I'm going to use my own stuff. And now your troubles really begin to multiply, don't they? They turn to shadow IT just to do their job. Collide is completely different. It's brilliant. I love this idea. Instead of forcing changes on users, Collide sends them security recommendations via Slack. Collide will automatically notify your team when their devices are insecure, but it doesn't stop there. It then explains, why it's insecure, why you shouldn't, leave your private key in public in your download folder, that kind of thing. And it'll send them then information, step-by-step instructions on how to solve the problem. And you know what? Suddenly, it's the IKEA effect. When users are doing it for themselves, instead of something being imposed on them, they own it, and they're attached to it. And they are suddenly attached to your success, keeping the business secure. As an IT administrator, you'll love it because Collide gives you a single dashboard that lets you monitor the security of your entire fleet, whether they're running on Mac or Windows or Linux. Yes, totally cross-platform. You'll see at a glance which employees, have their disks encrypted or their OS up to date, or are using a password manager. You are using a password manager, right? Making it easy to prove compliance to your auditors, customers, and leadership. And when you're reaching out to employees with a friendly, automated Slack DM, educating them about security, about company policies, you're building a culture in which everybody contributes to security because everybody understands how and why to do it. And doesn't that sound like nirvana? And it is totally, totally possible. With Collide, user-centered, cross-platform endpoint security for teams that slack. You can meet your compliance goals by putting users first. Honest. Just have to trust me on this one. It really works. Visit collide.com/security now to find out how. If you follow that link, they'll hook you up with a goodie bag, including a t-shirt just for activating a free trial. KOLIDE. This is my favorite. I have a couple. This is it says Collide on the back, but on the front it's just got a bunch of Pinocchios with longer and longer noses, except for one right next to the words honest security, right? I also have a Collide sticker on my laptop. I got a Collide coaster from a bear. Go to collide.com/security now. Get your goodie bag and activate that free trial. It's a little scary, I know, at first, but if you think about it, this is the right way to do it. And when you have a whole army of users protecting your security, you feel much better. You're not all alone. KOLIDE.com/security. Now, we thank Collide so much for supporting Security Now. You support us, of course, when you go there, get your goodie bag, and you use that URL so they know you saw it here. Collide.com/security now. Now, on with the show and Mr. Stephen Gibson.
Speaking of putting glue in the USB ports.
Yes.
A little tidbit that crossed while I was putting the podcast together, but I didn't lock it down into the show notes, was that someone plugged his USB rechargeable vape stick into his Mac.
Yeah.
And up popped a screen asking that this thing wanted permission to access his computer.
OMG. What the what?
So we've talked about the USB condom, which these vape stick users should be using, because this is not something that you want to have happen, obviously. Yeah. Okay. So speaking of network vulnerabilities, last week there was a worry about the possible impact of a TCP/IP remote code execution vulnerability in Windows. That's an eye-opener, since the assumption is that it's a problem in the core kernel code where the TCP/IP stack lives. And the worry was heightened by the fact that a proof-of-concept exploit was published to GitHub by researchers at Newman Cyber Labs, who had reverse-engineered the vulnerability through patch analysis. Again, Windows patched it, and you can look at the difference between what was there before and what's there now and figure out what's going on. But the fact that there were patches to analyze, as I said, meant that the problem had already been patched, as indeed it had been nearly 2 years previous, and this was in September's Patch Tuesday. Now, after reading through their research, it became clear that the conditions required for this vulnerability to be abused in the field were unlikely to occur. So it was mostly a theoretical vulnerability. I was shaking my head when I saw that the trouble was caused by fragmented packet reassembly in IPv6's IPsec handling. How many times, now this would only apply to listeners of the podcast forever, but how many times in the years of this podcast, when we were discussing the low-level technologies of the IP protocols back in the early days, did we encounter exploitable bugs resulting from the attempt to reassemble fragmented IP packets? It turns out it's just difficult to do that. And I think in the stack that I wrote for Shields Up, I think I just ignore fragmented packets when they come in fragmented, because it should actually never happen any longer. It's legacy need. Anyway, it was a constant theme for us in the old days. So, in any event, nothing widespread will amount from this. It's too specific, rare, and it's been patched for 2 months. But this will be one of the growing number of vulnerabilities that major long-term nation-state players will add into their known exploits database for possible selective deployment when they encounter a still unpatched system which qualifies for this very specific vector of attack. Though I have no first-hand knowledge of or any evidence of this being done, there's just no chance that such databases do not exist in the world today. If someone were to put me in charge of the United States, process for this, or, similar people in China or Russia, in charge of their cyber warfare effort, given what we know, given that we know that vulnerabilities never really die, creating such a database would be the first thing you would do. Because when someone says to you, we need to get into this person's system, this specific system, you inventory that system, you look at what you can determine about that system, and then you query your database of known exploits that specifically target that system, and then you start going down the list in order to find your way in. That's just the way it's going to be done. Probably is being done right now. Okay, and speaking of proofs of concepts published on GitHub, I wanted to warn any of our listeners who might enjoy grabbing and trying such proof of concepts for themselves that a just published study of GitHub's hosted proof of concepts found that a surprisingly high percentage of all of them were deliberately malicious. 3 academic researchers at the Leiden Institute of Advanced Computer Science at the Leiden University in the Netherlands published their research titled A Study of Malicious CVE Proof of Concept Exploits in GitHub. The abstract of their paper explains, they said, proof of concept exploits for known vulnerabilities are widely shared in the security community. They help security analysts to learn from each other, and they facilitate security assessments and red teaming tasks. Of course, we also know that they make it easier for bad guys to turn those proofs of concepts into actually aggressive malicious code, and that's a problem. In recent years, they said, POCs have been widely distributed, for example, via dedicated websites and platforms, also via public code repositories like GitHub. However, public code repositories do not provide any guarantees that any given POC comes from a trustworthy source, or even that it simply does exactly what it's supposed to do. In this work, we investigate POCs shared on GitHub for known vulnerabilities discovered from 2017 through 2021. We discovered that not all POCs are trustworthy. Some proof of concepts are fake. In other words, they do not actually offer POC functionality, or even malicious. For example, they attempt to exfiltrate data from the system they're being run on, or they try to install malware on the system. To address this, we have proposed an approach to detect if a POC is malicious. Our approach relies on detecting the symptoms we've observed in the collected data set. For example, calls to malicious IP addresses, encoded malicious code, or included Trojanized binaries. With this approach, we discovered, get this, 4,893 malicious repositories out of 47,313.
That's like 10%.
Yes.
No, that's 1%, but still a large number.
No, you were right first.
Oh.
10.3%.
Wow.
10.3%, more than 1 in 10 of the studied repositories have symptoms of malicious intent. They said this figure shows a worrying prevalence of dangerous malicious proof of concepts among the exploit code distributed on GitHub. So, we've previously noted here that code repositories such as NPM and PyPy have become laced with malicious fake libraries. So I wanted to make sure that everyone knew that now, sadly, GitHub's published POCs need to be treated with similar caution. As has often been said, we can't have nice things.
So these are repositories labeled as proof of concept of malicious code.
Yes, proof of concepts of vulnerabilities.
Right.
So a vulnerability exists. Someone said, "Here's a proof of concept."
It's an example of malicious code.
An example of how to exploit the vulnerability. So it's not itself vulnerable. For example, you run it and it pops up the calculator.exe.
Right. It says, see what I did? Yeah.
Even though you're not supposed to.
Except many of them are malicious in and of themselves.
1 in 10 of
I would like to know though what they call the signs of malicious intent are. I mean,
contacting a known malicious IP.
Right.
Or having embedded malicious code which has been obfuscated
and is unrelated to the exploit being demonstrated.
Yes.
That's the key to me. Because obviously it is malicious code. It's a demonstration of malicious code. So it might have to contact that server, for instance. But if it's unrelated or it's trying to hide something, then maybe.
Well, no. So it's not a demonstration of malicious code. It's a proof of concept
of a vulnerability.
A demonstration of a vulnerability. So it's like, there's this vulnerability in SQL. Here's some code to show you how, to benignly, I mean, these are always meant to be, but to benignly show how to use the vulnerability to exploit it. It doesn't actually do anything bad. It just says, "Hi, Mom."
Right.
But the idea
I was
is
able to do this. Right. Yeah.
Yes, exactly. And you should not have been able to do that.
Right.
Oh, look, Johnny drop tables. Whoops.
Yeah.
The Johnny table is gone now. So that's not good. So anyway, so the point is just, proceed with caution. Don't assume that a white hat hacker posted a proof of concept for something you're all hot and bothered about finding out how to do yourself. Treat it with care, because more than 1 in 10 do not have your best interests at heart. They're taking advantage of what was the presumed sort of trust among developers.
Yeah.
Okay, and winning without contest, the title for the best named vulnerability write-up of the year. We have a potentially serious SQLite exploited flaw named Stranger Strings. Great name. The concept, or the concern of this, behind this, is significant, because this flaw was first introduced into SQLite version 1.0.12, which was released on October 17th of the year 2000, more than 22 years ago. And it was only just recently fixed in release 3.39.2, which was released this summer on July 21st, 2022. In other words, this flaw has been present in SQLite for 22 years. And the biggest problem, if you might be thinking, SQLite, I don't use that. The biggest problem is SQLite is by far the most popular embedded database, which is used quite literally everywhere.
Oh, yeah, absolutely. Yeah.
To get a quick sanity check just now, as I was putting the show notes together, I opened a command prompt, switched to the root directory of my primary system drive, and I entered the command dir space star, asterisk, SQLite *** space / S meaning check all subdirectories. And the text console exploded with hits and scrolled off into oblivion. One thing I immediately noticed was that if you have anything from Mozilla, you've got lots of SQLite. Mozilla loves their SQLite for Firefox and Thunderbird in my cases. Okay, since this was too much information, I tightened the search to just the SQLite DLL. So I did a dir command. First of all, I cleared the screen because I wanted to get my console back. I mean, it was just literally, it was like the thumb just scrolled off to the nowhere. So clear the screen, dir space *SQLite.dll/s. And the result was far more useful and much more chilling. The apps I have installed on my system, which embed the SQLite database engine, some of which I use frequently, but many others which I haven't used after first installing them, are Nova PDF 9, Zend Studio, Acrobat 9, Amazon's Kindle Reader, AutoIt, NetBeans, Perl's CPAN library, Python, Microsoft Edge, Thunderbird Firefox, FreeCAD, Calibre 2, Streamcatcher Pro, Networks, that little network app I talked about last week, even it, PingPlotter, and PHP. And not one of these is an explicit database app. SQLite is the way the world's apps organize any data that they are being asked to retain, even if it's just user preference settings. So here's what the Stranger Strings guys had to say. Stranger Strings is what they called this. They're from Trail of Bits. And they said, Trail of Bits is publicly disclosing CVE 2022-35737, which affects applications that use the SQLite Library API. CVE 2022-35737 was introduced in SQLite version 1.0.12, released on October 17, 2000, and fixed in release 3.39.2, released on July 21, 2022. In other words, 22 years. And what that means, every single copy of SQLite that everybody has, unless it's been fixed, and it probably hasn't, is vulnerable to this. They said it's exploitable on 64-bit systems, and exploitability depends on how the program is compiled. Arbitrary code execution is confirmed when the library is compiled without stack canaries, but unconfirmed when stack canaries are present, and denial of service is confirmed in all cases. Now, just to remind everybody, a stack canary is something which the compiler can be asked to stick on the stack in order to protect from stack overrun. The idea is that when you perform a return to using the contents of the stack to decide where to go, before the program does it, it verifies a cookie on the stack has not been overwritten before assuming that the stack has not been smashed. So it is possible that the SQLite library has been compiled with those cookies on the stack, in which cases the app will crash rather than execute malicious code. They said on vulnerable system, but I have no knowledge of whether or not stack cookies are typically compiled into binaries of SQLite. If somebody does, shoot me a note. On vulnerable systems, 35737 is exploitable when large string inputs are passed to the SQLite implementations of the printf functions, and when the format string contains the %q, uppercase q, %lowercase q, or %w format substitution types. And not too long ago, we're talking about printf problems. Anyway, this is enough to cause the program to crash. We also show that if the format string contains the exclamation special character to enable Unicode character scanning, then it is possible to achieve arbitrary code execution in the worst case, or to cause the program to hang and loop nearly indefinitely. They said SQLite is used in nearly everything, echoing my comment, from naval warships to smartphones to other programming languages. The open source database engine has a long history of being very secure. Many CVEs that are initially pinned to SQLite actually don't impact it at all. This blog post describes the vulnerability and our proof of concept exploits, which actually does impact certain versions of SQLite. Although this bug may be difficult to reach in deployed applications, it is a prime example of a vulnerability that's made easier to exploit by what they called divergent representations that result from applying compiler optimizations to undefined behavior. In an upcoming blog post, we'll show how to find instances of the divergent representations bug in binaries and source code. They said a recent blog post presented a vulnerability in PHP that seemed like the perfect candidate for a variant analysis. The blog's bug manifested when a 64-bit unsigned integer string length was implicitly converted into a 32-bit signed integer when passed as an argument to a function. So there was an implicit type conversion flaw. In fact, we talked about one of those not long ago. They said, we formulated a variant analysis for this bug case, found a few bugs, and while most of them were banal, one in particular stood out. A function used for properly escaping quote characters in the PHP PDO SQLite module, and thus began our strange journey into SQLite string formatting. Anyway, they go on and on. Their posting, I have a link to it in the show notes, is extensive and interesting. They did have a great piece of commentary toward the end about the testing of SQLite and how this high-severity flaw happened and remained hidden for 22 years. They said, SQLite, and this is actually comforting, SQLite is extensively tested with 100% branch test coverage, meaning every single branch in the code receives a test. They said, we discovered this vulnerability despite these tests, which raises the question, how did the tests miss it? SQLite maintains an internal memory limit of 1 gigabyte, so the vulnerability is not reachable in the SQLite program. The program is defined away by the notion that SQLite does not support big strings necessary to trigger this vulnerability. However, the C APIs, SQLite is 100% written in C and highly cross-platform portable. They said, however, the C APIs provided by SQLite do not enforce that their inputs adhere to the memory limit, and applications are able to call the vulnerable functions directly. The notion that large strings are unsupported by SQLite is not communicated with the API, so application developers cannot know how to enforce input size limits on these functions. When this code was first written, most processors had 32-bit registers and 4 gigabytes of addressable memory. So allocating 1 gigabyte strings as input was impractical. Now that 64-bit processors are quite common, allocating such large strings is feasible, and the vulnerable conditions are reachable, where before, historically, they weren't, which I think is really interesting. This essentially surfaced because we went to 64 bits, and now that conversion from 64-bit lengths to 32-bit lengths, which could never have been a problem before, suddenly could be. They said, unfortunately, this vulnerability is an example of one where extensive branch test coverage does not help because because no new code paths are introduced. 100% branch coverage says that every line of code has been executed, but not how many times. This vulnerability is the result of invalid data that causes code to execute billions of times more than it should. The thoroughness of SQLite's tests is remarkable. The discovery of this vulnerability should not be taken as a knock on the robustness of these tests. In fact, we wish more projects put as much emphasis on testing as SQLite does. Nevertheless, this bug is evidence that even the best tested software can have exploitable bugs. So on July 14th of this year, 2022, they reported the vulnerability, which they discovered, to the CERT Coordination Center. On the 15th, CERT CC reported the vulnerability to SQLite's maintainers. On the 18th, the SQLite maintainers confirmed the vulnerability and fixed it in the source code. And on July 21st, the SQLite maintainers released SQLite version 3.39.2, which included the fix. The problem, of course, again, is that many and probably most of the individual applications which each brought along their own private copy of what is now a theoretically vulnerable SQLite engine have not subsequently been updated. None of those things that I talked about, most of those have been updated since July. So what do these guys say about this? How do they appraise the real threat, if any, that this represents? They wrote, not every system or application that uses the SQLite printf functions is vulnerable. For those that are, CVE 2022-35737 is a critical vulnerability that can allow attackers to crash or control programs. The bug has been particularly interesting to analyze for a few reasons. For one, the inputs required to reach the bug condition are very large, which makes it difficult for traditional fuzzers to reach, and so techniques like static and manual analysis were required to find it. You wouldn't find it just by throwing crap at the wall and seeing if something crashed. For another, they said, it's a bug that may not have seemed like an error at the time that it was written, dating back to 2000 in the SQLite source code, when systems were primarily 32-bit architectures. So, here again, we have a bug that's very much like Log4j. It's buried, unseen, inside random applications, many of which will never be updated since everything is working just fine. Highly active and maintained apps like Firefox, Thunderbird, and Edge have all likely already updated their code, but many others never will. We can hope that no remotely accessible applications would be vulnerable to this, and it seems unlikely that any would be. But like so many other similar problems we've seen, this adds again to the growing list of latent known vulnerabilities which riddle today's software systems. A quick note that PayPal said they're going to be starting to support passkeys. Last week, they announced their support for passkeys. As a PayPal user, I'm super interested in having this experience, as I would imagine most of our listeners are, since coverage of PayPal's announcement appeared to suggest that the support was already there, but PayPal's press release was not specific. They said, dated October 24th, 2022, PR Newswire, today, PayPal announced it is adding passkeys as a secure login method for PayPal accounts. So I just logged into PayPal through Safari on my iPhone with iOS 16.1, and I was unable to see any option for passkeys anywhere. And I mean, I really dug around. So I'll ask any other PayPal using listener who uses Twitter to shoot me a tweet if and when they actually see that PayPal's support for passkeys has gone live. A lot of the press coverage of this, it got a lot of coverage, and many of the coverage said that it's there. But if they actually saw it or found it, I was unable to. So, but cool that would be there. I would love to, have this experience, see how it works.
On the sign-in screen, tap the account name field, type other options. Passkey from nearby device or similar. I don't know. I'm just looking at this is from Apple, not from PayPal. I'll try it while we're. You do have to. It looks like on your phone for a new account on the account sign-up screen, enter an account name. When you see an option to save a passkey, so something has to pop up. Let's see, on an existing account, which is used, sign in with your password, then go to the account management screen where you should see that option. I'll try it. I'll try it. I'll get back to you.
Cool. One very cool thing, the last thing I need to share with everyone is potentially quite exciting for the right sort of listener. CrowdStrike's Jack Halon has just released the first of his 3-part extensive tutorial series titled Chrome Browser Exploitation. And as I mentioned, and we had fun with at the top of the show, I was so relieved to see that it was not on YouTube. Jack's tutorial leads its reader through the details of exactly how to poke at Chrome. He tweeted, "Today, I'm finally releasing a new 3-part browser exploitation series on Chrome. This was written to help beginners break into the browser exploitation field. Part 1 covers V8 internals, such as objects, properties, and memory optimizations. Enjoy." So I've got a link to it in the show notes. It's on github.io, jhalon.github.io, Chrome-browser-exploitation, and -1 for part 1. So I think many of our listeners might find that interesting. Two pieces of miscellany. So many people tweeted to me about the recent passing of Kathleen Booth. At the age of 100, she was born on July 9th, 1922, and lived until September 29th, just a couple days ago. Anyway, I wanted to thank everyone for making sure I knew. Kathleen was a very early pioneer of stored program digital computers. She developed and built several machines through the course of her life. And the reason for everyone's tweets is that she's credited with developing an early notation for her machine's instructions, which she referred to as contracted notation. It's considered to be the earliest predecessor of what today we now call assembly language. And of course, everyone knows of my fondness for assembly language. Kathleen remained very active with computers and computation throughout her life. And in 1993, she co-authored a book on neural networks titled Using Neural Nets to Identify Marine Mammals with her son, Dr. Ian Booth. So, quite a remarkable woman. And thank you to everyone who wanted to make sure that I knew. Okay, bit of closing the loop. Humili Math tweeted, he said, "The wonders of OS provability reminds me of Knuth," which, and Donald was quoted, "Beware of bugs in the above code. I have only proved it correct, not tried it."
Of course, famously, he wrote all of his code as in a pseudocode that doesn't actually run on anything. I think it's called Mix. I'm trying to remember the name.
Yes, Mix. Yeah, Mix. Mix was the pseudo machine that he wrote his code for.
Yeah.
And anyway, he's got a great sense of humor, and he's famous for that. So
I think
beware
he couldn't
of bugs
run it.
in the above code. I have only proved it correct, not tried it. Someone tweeted to me from their name is Cal, and he said, "At SGGRC, glad you tried Edge for SN894. Did you get to try the built-in, no extension needed vertical tabs? They're the best implementation I've ever seen. Also, you could use uBlock Origin Lite in Firefox and Chromium browsers now. It's compatible with Manifest v3. And Cal, to answer your question, and everybody else's, yes. The first thing I did was turn on vertical tabs in Edge. I used it again yesterday and actually all morning. So I like it a lot. David Flint said, listening to SN894 and the discussion on the proposed Australian legislation, is a possible benefit of the strict liability for data breach, not a possible reason for the breached entity to pressure Microsoft into taking responsibility for the flaws in their software. Oh, were it so. He says, as you yourself have said, it is not impossible to produce perfect software. It just takes time and effort. That seismic change can only be a benefit. Well, I certainly agree on that issue, David. At this point, with their size and grip on the world's personal and mostly enterprise desktops, Microsoft is utterly untouchable. Their market value, their stock evaluation is the only thing that I can imagine swaying them, and really nothing puts them at risk. They're too big to care. The licensing agreements hold Microsoft harmless for any behavior of their software and systems, and none, not one, of the things they have chosen not to care about endanger their position. We're occupying a world where now, for the enterprise, which they've clearly indicated is the only thing they care about, there is no practical alternative to Microsoft. So there's nowhere for anyone to go. Alan Wilkins, he said, can a new form of cryptography solve the internet's privacy problem? Okay, that's an interesting question. And the answer is no, because our current cryptography is not the problem. Today's crypto, when it's done right, is utterly unbreakable. It can and does provide perfect privacy. The problem is that data that's been encrypted will eventually be decrypted. After all, it's only useful after it's been decrypted. And as soon as it's decrypted, privacy problems arise. If the data remains encrypted, no problem. But if you're never going to decrypt it, you might as well delete it, in which case, again, no problem. But also, then no data. So the problem is not with the encryption or with the crypto. It's what happens the rest of the time.
You got mail.
I turned that off. But it's still, why is it talking to me?
Is that Pebbles?
I guess I turned it back on. It dates from the days of CompuServe.
Oh,
Somebody
wow.
on CompuServe who
Oh,
had
it was
that
their kid. I remember
file.
that. Yeah.
Yeah, 4-year-old. Adam Jamal Craig, he said, there comes a time in every programmer's life where they try to optimize their layer 0 I/O keyboard workflow. Have you ever tried alternative keyboards? He said, and then he lists Kinesis, Split, or other ergonomic keyboards, or alt keyboard layouts, Dvorak, Colmac, etc. And my answer is I never have. My first wife's nickname for me, the one I can repeat in public, was Creature of Habit.
Yes.
Which was quite appropriate.
She knew you well, I think.
Creature of Habit.
Yes.
I appear to be extremely sensitive to any change whatsoever in my keyboards. My perfect world would have a limitless supply of cream-colored Northgate OmniKey 102 super rigid and clanky keyboards with a high actuation force. The control key must be to the left of the A key, with the function keys to the left of them in 2 vertical columns where they're easily accessible, not arranged along the top where they're virtually unreachable.
You like the old IBM layout with the function keys
yes.
on the left.
I don't like it, Leo. It is where they're supposed to be.
I haven't seen a keyboard with it that way in a long time, and that's why you've saved those Northgates.
I'm sitting in front of it right now.
Wow, I forgot about that.
Then to the right is the inverted T navigation pad, and at the far right is the 10-key numeric pad with the num lock permanently off. By some grace of God, I am sitting in front of that keyboard right now, and I have another at my other location. Both are still working after 35 years, knock on wood.
They're probably pretty clicky too, aren't they?
Oh my God. I have to be, while you were talking, I was typing something very as quietly as I could, but you can't be. So the beauty of this keyboard, which has been in front of me, think about it, for more than half of my life.
Wow.
Because I'm 67 and I've had it for the most recent 35 years, is that my brain appears to be directly connected to it. If I stop to think about typing, I stumble. But if I don't think, I just do, then text and actions flow unbidden. Now, yes, I've tried other keyboards. The closest key switch...
Is this it?
Nope. Because the function keys are along the top. Wait,
well, there's also on the left. You get the best of both worlds.
That's interesting.
This is the OmniKey Ultra, which is a newer...
Although, there's a problem. The escape key is up there in the top.
Oh, that's no good. No.
It can't have that. It's supposed to be where the back tick is, to the right of the numeric 1.
Yeah.
I don't know. So the closest key switch I found is the Cherry MX Blue.
Yes.
It has the highest actuation force with the most clicky snap action. I need both. There are keyboards I could switch to if I really had to, but I already have some keyboard repair kits standing by, waiting for the day that I'll need to bring one of these beasties that I have back to life.
There are people who rejuvenate these and sell them, and they sell them at great price, I might add. Hundreds of dollars. Yeah.
Yes.
Yeah. Did you have these originally?
Yes.
These are your original.
I bought these from Art. What was this? Art something.
Lebedev?
At Northgate Computer.
Oh, at Northgate Computer. Yeah. So, this is a function
there it is.
key. Is this it? No, it says function keys.
Yeah, you got to go back to the 102. Is that a 102?
It says 102.
It's not the 102.
But it's a phony 102.
Yeah. Close,
but no cigar. Close. See, I use the tilde and backtick in Lisp and Emacs.
Well, I do too. I've got one. It's just not in the wrong place.
Of course not. Now you make me want these. I want one of these.
Oh, they're so nice, Leo. They're clanky, and it's got a PS2 connector, so then you need a PS2 to USB converter.
Yeah, I have a Model M, an old IBM Model M that uses that. Yeah,
nice.
But no, not as nice as yours though. I now want function keys on the left.
That's where they're supposed
kids
to be.
who are listening said, "What?
That's where they're supposed to be."
Talking
Word
about?
Perfect. Remember Word Perfect?
Yes.
It used the crap out of those. You had Control F5 and Alt F10, and you could just do anything with that. Oh, those are the days. So as for optimizing my workflow, this is why I just did want to mention, this is why I spent the time before I started back on the work on SpinRite, nailing down my development environment. And I am so glad I did. I'm now able to make an edit to SpinRite's source in Visual Studio in Windows. I hit Alt-A, which is for assemble, which builds the entire project by the time I've released the A key. Then I turn to the keyboard attached to the utterly quiet Zima board, which is at my right elbow, and type G on that keyboard, which is short for Go, which executes a DOS batch file to load and run SpinRite under Brett Salter's, who unfortunately we lost a couple years ago, DOS Periscope debugger from the directory it shares over the network with my Windows machine. The whole experience is a joy, and I'm going to keep at it. After SpinRite 6.1, we're going to go to 7 and 7.1 and 7.2 with an equally, perfect environment. And speaking of alt keys and so forth, Gordon looks like Helvenka. He said, surely you must have known. Okay, Gordon. That
surely,
at least...
Wait a minute, no, you didn't say it right. Surely you must have known.
That's right. That at least since Windows 3.x, Control-Tab will switch between child windows of an app.
Surely.
Since the invention of browser tabs, this has also worked to switch between tabs. In the same vein, Control F4 will close a tab or child window. These aren't limited to browsers, of course. You can switch between Word documents, for instance. And Gordon, yes. And I use all of those constantly because like our wonderful Paul, who is a Windows, keyboard shortcut maven, I've been doing that too. My assembly code, as I mentioned, is broken into many files of function. It's into many files by function. So in Visual Studio, I'll often be collecting too many open files that I'm no longer working in. So Control F4, I use that repeatedly to close them quickly. But what I was talking about, just to be clear, was Alt-Tab, which in all my previous experience only switches among top-level application windows. But here again on Monday, here I was working on this. I'm in Edge and using Alt-Tab to quickly jump among Edge's most recently viewed tabs. It's great, but it came as a surprise to me. And there's another crucial difference between Alt-Tab and Control-Tab. Alt-Tab uses an MRU, explicitly a most recently used list, so that Alt-Tab takes you back to where you most recently were, whereas Control-Tab always moves forward in strict round-robin sequence. So MRU is the most useful sequence for me. What's this one? Simon, tweeting from @talk_to Simon, he sent a link to a useful rant posted at medium.com by a guy who discovered that PayPal's login dialog was far too helpful. It turns out it's true. It's really shocking, Leo. You're not going to believe this.
Okay.
That completely separate and completely bypassing any and all other measures that a PayPal user may have set up on their account, including their password and any form of second-factor authentication, and probably including passkeys, we'll see once it gets there, there's always the option of providing your email address to identify yourself, then clicking the Log in with one-time code button, which is always there and which will send a 6-digit code via SMS to the user's phone. We know that SMS is not secure, so there's that. But maddeningly, there is nothing that any PayPal user can do to prevent this short-circuiting of any and all other means of login. I use PayPal. I use PayPal a lot. So I have my account set up with a long and gnarly password that no sane person could possibly enter correctly, and a TOTP, right? A time-based one-time password. And my trusty authenticator app has an entry for PayPal. But all of that is for naught if an attacker can arrange to somehow intercept my phone's SMS messaging stream. If so, they can log in with the code they receive and use nothing else. Nothing. The debate with PayPal's customer support has been raging over this for more than a year. And the only thing PayPal will say over and over is, quote, "This feature is permanently enabled for the protection of our customers," unquote. Well, we know what this is about, right? We've seen this enough on this podcast to understand that PayPal's less sophisticated users must be provided with a backdoor into their accounts. You can't actually have security for something like this, or users will be frustrated when they cannot arrange to access their own money, even when it's entirely their fault that they cannot. So as a result, every PayPal user's security is reduced to this lowest common denominator in order to accommodate the few.
Wow. So just avoid getting SIM jacked.
Yep.
Do you think eSIMs, this new Apple eSIM thing, well, it's not new and Apple doesn't own it, but Apple's put it in all their new iPhones, will help with that? Or does that make it easier?
I don't know.
Yeah.
Because, certainly there is the problem of physically swapping SIMs, but the biggest problem is that, as we know, our telephone system is still actually not very secure.
It's not secure. SS7 is
always
will be, because they're never going to fix it. Yeah.
Yeah. Okay. A little comment, an update on where I am with SpinRite. I had a number of things to fix and finish in SpinRite since I last spoke of it. Mostly, none of the new drivers had ever been exercised in the presence of unreadable sectors, which we talked about recently, my ability to deliberately create flaws. Until now, we've all been testing on fully readable drives. Some of the documentation, it turned out, in the official AHCI controller spec, to which I had blindly written code, because I had no choice at that point, was revealed to be more ambiguous than I knew. So that necessitated that I re-engineer the means for determining which sectors failed amid a 32,000 sector read. So I did that. I've tested the crap out of it now. It's now working beautifully. Then, with the ability to induce and locate defective sectors, I was able to work through SpinRite's entire data recovery system. Now that's all done and working as well and tested. Then I turned my attention to the detailed event logging system, which needed major reworking to bring it into alignment with the various things that can now be reported, since SpinRite has direct access to the system's mass storage hardware, and all that's done too. Next up is performing the same defective sector relocation or location testing for SpinRite's 4 other drivers: the new bus mastering DMA driver, its new IDE hardware driver, and then both its basic and extended BIOS drivers. And I've already started to work on those. So I reasonably expect to be finished with that by the end of this week. Then the final thing I need to do is revisit SpinRite's command line options to update them where needed. There are things that some additional features due to the fact that I have hardware access now, like I can determine drives' serial numbers, and so it'd be nice to be able to allow the user to specify which drive they want to use through the command line by specifying the serial number of a drive they know they want to test. So anyway, that way, even if the drive should move around in the drive listing as other drives come and go, or as the BIOS reorders drives, the user will always be able to select the drive they intend. At that point, SpinRite 6.1 will be feature complete, so we're close. And it will have been finished with some confidence, and I'll consider it to be at alpha stage. So I'll update GRC server to enable our testers to obtain their personally licensed test releases of it, and will eliminate any problems that I have missed and that have been missed by all of our previous testing. I haven't mentioned it before, but I received news about a month ago that the commercial embedded operating system I've chosen for SpinRite's future will be leaving the market at the end of the year.
So you're moving away from FreeDOS.
Moving away from FreeDOS. And this is something I've been worried about since I recognized it could happen at any time. I'm not surprised by this, actually, since this on-time RTOS 32 OS is old and mature, and there is now so much competition in the embedded processor market. Intel x86 chips are much more oriented to high-end desktop processing, and there are a huge number of lower-end chips that make much more sense for embedded applications. So I strongly suspect that the licensing revenue for this thing has dried up quite a while ago, and the guys finally decided, okay, it's just not worth keeping this up. Now, I'm not put off by the idea of a lack of support, since I was planning to purchase the source code for this commercial system anyway.
Oh, okay.
So that I could fully customize it and extend it in any way that I might need for several more decades that I plan to be working on this. But this end of the year deadline means that I need to make sure that it's what I want and to commit to it before it disappears, which means billing up to the bar and buying a very expensive source code license for this entire commercial OS. So, while the SpinRite testing gang is pounding on the fresh 6.1 alpha release, I'm going to overlap their testing with my own testing of OnTime's OS to make sure that I like its development environment and that I'm able to dual boot my code both on BIOS and UEFI, which is the whole reason I'm doing this. I'll just create a very simple Hello World app to test that. since purchasing the source code for this commercial OS will be a significant investment, I need to make sure that before I do it, it's going to be something that I'm going to want to use. So when that's done, I'll incorporate any suggestions our testers have come up with. I'll fix anything that they found that's not working, and we'll move SpinRite to its pre-release beta stage. And needless to say, it's feeling really great to see this project nearing its long-awaited conclusion.
Yes, sir. Very exciting.
And speaking of a long-awaited conclusion,
yes,
Leo, there's a long-awaited conclusion to this podcast at this point. So
let's hustle it along by doing our last ad as you prepare your story of 20 years inside GCHQ.
Yep.
But first, a word from IT Pro TV. You've heard us talk about this before. In fact, I would bet that at least half of our audience already has joined IT Pro TV. My question is, why hasn't the other half? Because this is the greatest place to get into the world of IT if you're already in it, to upskill, to get new certs, to recertify, to get a better job. IT Pro TV. And if you've got an IT team in your business, you need IT Pro TV to keep them on their toes. Your IT team needs the skills, the knowledge to ensure your business success, right? This is a benefit you can give them that they will love and use, most importantly. This is something that they will appreciate. I know this for a couple of reasons. One, about 80%, actually a little more than 80% of all IT Pro TV users who start a video finish it. That means they're engaged. They don't lose interest. They don't wander off. Maybe partly because the videos are only 20 to 30 minutes, but I also think it has something to do with the fact that they're trainers at IT Pro TV. They call them edutainers, are experts in the field. I mean, they know their stuff. You know, the worst thing is to be learning something from a guy who's never done it, doesn't know it. These are men and women who have are working in the industry. Even more importantly, that they have a passion for what they're doing. So they communicate to you the excitement, the joy they get out of going to work every day. That's kind of important, right? You want your team to get that, right? That's something you want your team to get. An excitement about coming to work every day and solving problems, fixing things, getting things working. The IT industry is constantly changing too, and this is another reason why you'll really appreciate IT Pro TV. They have 7 studios. They're running all day, every day, Monday through Friday, to update and create new content because the tests change, the questions change, the software changes, the hardware changes. This is a fast-moving field. So you only really, I mean, this is why, getting a book at a bookstore or a library is not going to, it's going to be out of date by the time they print it. And often when you go to a technical school, their instructors haven't been actually working in the field in a long time. This stuff gets out of date instantly. This is what's great about IT Pro TV. You will not find fresher content. And by the way, every single IT subject, every cert, 5,800 hours of up-to-date IT training for Microsoft, Cisco, Linux, Apple, security, cloud, technical skills, compliance, even soft skills. This is the place to get the training your team needs to serve you and your business. And with the business plan, you get a great dashboard that lets you track your team's results. You can manage their seats, assign and unassigned team members. You'll get monthly usage reports that are graphical, that are visual, which makes it very easy to explain the spend to the higher ups. They like seeing that stuff like that. You'll get metrics like logins, viewing time, tracks completed. You can completely manage the users. It doesn't have to be a whole team. It could be a subset. It could be one guy, 2 guys. You can even say you take this individual course, and because all the courses have full human written transcripts, you can find the thing that your team or team member needs to learn and say, watch that, learn that, come back to me and report back. It is just a great way to learn that your team will really be grateful for, which means they'll use it. And of course, IT Pro TV, everything I just said goes for individuals too. If you want to get into IT, this is a great place to go. Give your team the IT development platform they need to level up their skills while enjoying the journey. itpro.tv/security now. Go there right now. This is the thing you've been looking for to keep your team up to date or yourself. itpro.tv/security. Now, we thank IT Pro TV. They've been sponsors of this show since they started. We grew together, and they're just doing great. itpro.tv/security now, and I thank you for using that address so they know you saw it with Steve. Thank you, IT Pro TV. All right, Steve, I think it is time to enter GCHQ.
So, as I said, this week's topic began as a Twitter DM from Jonathan Z. Simon. He said, Steve, thought you might appreciate this. The thoughts of the departing technical director of the UK National Cyber Security Centre. And as we know, I did appreciate what a 20-year veteran and technical director of the UK's NCSC, that's the National Cyber Security Centre, and GCHQ, whose name is Ian Levy, had to say about the valuable lessons he's learned. And I know that our listeners will benefit from it too. His posting was long, so I've edited it down for size, but I've otherwise changed as little as possible. His initial blog entry, his final blog entry, he titled it humorously, "So Long and Thanks for All the Bits." Of course, in reference to Douglas Adams' Hitchhiker's Guide sequel. So he said, it's with a heavy heart that I'm announcing that I'm leaving NCSC, GCHQ, and Crown Service. Being technical director of the NCSC has been the best job in the world and truly an honor. I spent more than 2 decades in GCHQ, with the last decade in this role and its prior incarnations. I've met and worked with some of the most amazing people, including some of the brightest people on the planet, and learned an awful lot. I've got to give a special mention to everyone in NCSC and wider GCHQ because they're awesome. I've also had the pleasure of working with vendors, regulators, wider industry, academia, international partners, and a whole bunch of others. I like to think I've done some good in this role, and I know I couldn't have accomplished as much without them. He says, regardless, there's a lot left to do. So I thought I'd leave by sharing 10 things I've learned and one idea for the future. And again, I've whittled those down. We won't go through all of them because some of them just weren't needed. He said, as a community, cybersecurity folk are simultaneously incredibly smart and incredibly dumb. This superposition doesn't seem to be unique to our community, though. In World War II, the Boeing B-17 Flying Fortress was the workhorse bomber of the U.S. As you'd expect, a lot of them were lost during combat, but a lot were lost when they were landing at base. Pilots were blamed. The training was blamed. Poor maintenance was blamed. Even the quality of the runways was blamed. None of this was supported by any evidence. After the war, someone actually did some research to try to understand the real problem. Imagine you've been on a stressful bombing raid for 12 hours without sleep. You're tired, it's dark, it's raining, and you're on final approach to your base. You reach over to throw the switch that engages the landing gear, and suddenly, with a lurch, your aircraft stalls and smashes into the ground, killing everyone. This picture of a B-17 cockpit instrument panel shows what the pilot would see. And at this point, he actually shows a picture of the B-17 cockpit instrument panel. There are 2 switches next to each other. One switch he has labeled Land Safely. The switch to its immediate right is labeled Die Horribly. He says, there's no amount of training in the world that could compensate for this design flaw. There's nothing to stop the most obvious error turning into a catastrophic outcome. The Land Safely switch, which operates the landing gear, and the Die Horribly switch, which operates the flaps, are very close to each other and identical.
Wow.
It turns out it was a UI flaw in the layout of the panel that was killing all of these people who were landing their B-17 bombers. So he says, blaming users for not being able to operate a terrible design safely. Sound familiar? But this investigation, he said, led to something called shape coding, which persists as a design language today. Most modern aircraft have a lever to operate the landing gear, and a little toggle on the end of the lever is wheel-shaped. So when you grab it, you know what you've got hold of.
Yeah, that's smart.
The flaps control is generally a big square knob. And guess what? They're not next to each other anymore. The aircraft world has learned from its mistakes. In cybersecurity, we come up with exquisite solutions to incredibly hard problems, manage risks that would make most people's toes curl, and get computers to do things nobody thought was possible, or in some cases desirable. But we also continue to place ridiculous demands on users. He says, take a deep breath, not to mention clicking links in emails or password policies. He says, implicitly expect arbitrary complex implementations of technology to be perfect and vulnerability-free in the long term, and then berate those who build the stuff we use when they fail to properly defend themselves from everything a hostile state can throw at them. I've always found this cognitive dissonance interesting, but I haven't found a way to reliably and easily work out when we're asking for daft things. The nearest I've got is to try to determine where the security burden lies and whether it's reasonable to ask that party to shoulder it. Is it reasonable to ask a 10-person software company to defend themselves from the Russians? No. Is it reasonable to ask a critical infrastructure company to not have their management systems connected to the internet with a password of secure password? Bloody right it is. The trick for making cybersecurity scalable in the long term is to get the various security burdens in the right place and incentivize the entities that need to manage those burdens properly. Sometimes the obvious person to manage a burden won't be the optimal one, so we may want to shift things around so they scale better. And let's be honest, we do suffer a lot from groupthink in cybersecurity. So here's my plea. The cybersecurity community should talk to people who aren't like us and actually listen to them. Stop blaming people who don't have our LEETS skills when something goes wrong. Build stuff that works for most people most of the time, rather than the easy or shiny thing. And put ourselves in the shoes of our users and ask if we're really being sensible in our applications and expectations. We haven't got that right yet. And he says, we're treating the symptoms, not the cause. He says this month marks the 50th anniversary of memory safety vulnerabilities. Back in October of 1972, a U.S. Air Force study first described a memory safety vulnerability. He says, page 61, although the whole 2-volume report is fascinating. In the 1960s, Aleph 1 published the seminal work titled Smashing the Stack for Fun and Profit, explaining how to exploit buffer overflows. In the first 3 months of 2022, there were about 400 memory safety vulnerabilities reported to the National Vulnerability Database. As Anderson et al. Say in their report, this is the result of a fundamental flaw in the design of the hardware and software we use today. The exact same fundamental flaw they identified in 1972, 50 years ago. Nothing has changed. And what is our response to this issue? Basically, we tell people to write better code and try harder. Sometimes we give them coping mechanisms, which we give cool-sounding names like static and dynamic analysis or taint tracking. But in the end, we blame the programmer. That's treating the symptoms, not the underlying cause, and once again harks back to the B17 design problem. I think we do that because fixing the real problem is hard. Doing so breaks a bunch of existing stuff. What was I saying last week about the operating system, which could be perfect, but it wouldn't run anything, right? It would break everything, nothing to run. Doing so costs people money. Doing so seems to be daft if you're in the commercial ecosystem, right? As I've also recently said, you don't get paid for doing something secure. This is where he says government can step in. Under the Digital Secure by Design program, we're funding the creation of a memory-safe microprocessor and associated toolchain. If this works, it won't fix the stuff we already have, but at least it'll be possible to build systems that can't be exploited through memory safety errors without expecting every programmer to be perfect all the time. All of the active cyber defense services are really treating the symptoms rather than the underlying causes. And I'm really proud of what we've achieved with the ACD program and we've used it to force some systemic changes. But even that program is about mitigating harm caused by the problems we see rather than fixing the problems. We really need to get to the root causes and solutions to some of these really thorny issues. For example, one problem, in my opinion, is that it's too easy to set up free hosting for your cybercrime site. There's no friction and no risk to dissuade would-be crims. Hosting companies that aren't incentivized to make it harder, because if one of them does it, they'll just lose customers to a competitor, which is commercial insanity. Should government regulate the provision of hostings? Almost certainly not, at least in democratic countries, but there's got to be some way of squaring this circle and the many other apparent paradoxes that have dogged cybersecurity for years. I've just not had the chance to work out how, so someone else needs to. Hint, hint. And he says, under much to learn you have, young Padawan. He says, there have been a couple of big incidents in the last year or so that have rocked the cybersecurity world. The attack on SolarWinds, now attributed to the Russian state, was hailed by some as a heinous, unacceptable attack. The vulnerability in the widely deployed Log4j component caused mass panic, only some of which was justified, and has kicked off a load of knee-jerk reactions around understanding software supply chains that aren't necessarily well thought through. Both of these attacks remind me of Groundhog Day. The Log4j problem is equivalent to the problem we had with the Heartbleed attack in 2014, despite being a different sort of vulnerability. The community had alighted on a good solution to a problem and reused the hell out of it. But we hadn't put the right support in place to make sure that that component, OpenSSL, was developed and maintained like the security of the world depended upon it, because it did. The SolarWinds issue was a supply chain attack, going after a supplier to get to your real target. It's not the first time we've seen that either. Back in 2002, someone borked the distribution server for the most popular email server program, SendMail. And for months, many servers on the internet were running compromised code. That same year, OpenSSH distribution was borked to compromise people who built that product to provide secure access to their enterprise. He says, my point here is that we rarely learn from the past or generalize from the point problems we see to the more general case. To get ahead of the attackers, going back to the aircraft analogy, if that industry managed risk and vulnerability the way we do in cybersecurity, there would be planes literally falling out of the sky. We should learn from that sector and the safety industry more generally. The U.S. have set up the Cyber Safety Review Board based on the National Transportation Safety Board, which will hopefully be a first step in systematizing learnings from incidents and the like to drive change in the cybersecurity ecosystem. At the moment, it's only looking at major incidents, but it's a start. I hope the community supports this and similar efforts and helps them scale and move from just looking at incidents to tackling some of the underlying issues we all need fixing. Without some sort of feedback loop, we're destined to be a bit dumb forever. And finally, he says, incentives really matter. He says, imagine you're a consumer who's about to switch broadband providers, and you want to compare two companies. One offers to send you a 60-page document describing how it secures the PE and P nodes in its MPLS network, how the OLTs in the fiber network are managed, and how much effort it puts into making sure the ONT in your house is built and supported. The other one offers you free Netflix. Of course, everyone chooses the ISP with the free Netflix.
Of course.
In the telecom sector, customers don't pay for security. So there's no incentive to do more for your customers, which is what would drive the sector to get better. He says, that's where regulation can help and is one of the reasons that we, with DCMS, pushed so hard for what became the Telecoms Security Act. The detailed security requirements in the Code of Practice make it clear what's expected of telecoms operators, and the fines Ofcom can levy when that's met are material. We're already seeing this drive better outcomes in the sector. If you ask anyone in the intelligence community who was responsible for the SolarWinds attack I referenced earlier, they'll say it was the Russian Foreign Intelligence Service, the SVR. But Matt Stoller makes an interesting argument in his article that it's actually the ownership model for the company that's really the underlying issue. The private equity house that owns SolarWinds acted like an entity that wanted to make money rather than one that wanted to promote secure software development and operations. Who knew? And Leo, if you remember thinking back to SolarWinds, there were some problems in the way they were managing their software that made no sense to us at the time. It's because they're owned by private equity that just wants to squeeze it for money. He says, now I don't agree with everything Matt says in his article, but it's hard not to link the commercial approach of the company with the incentive and capability of the people in it. It's then hard not to link the actions of those people, driven by their incentives and capabilities, with the set of circumstances that led to the attack being so easy for the Russians. Of course, the blame still sits with the SVR, but did we accidentally make it easier for them? In both cases, the companies are doing exactly what they're supposed to do, generate shareholder value. But we implicitly expect these companies to manage our national security risk by proxy, often without even telling them. Even in the best case, their commercial risk model is not the same as the national security risk model, and their commercial incentives are definitely not aligned with managing long-term national security. In the likely case, it's worse. So I think we need to stop just shouting, do more security at companies and help incentivize them to do what we need long term. Sometimes that will be regulation, like the Telecom Security Act, but not always. Sometimes we're going to have, shock horror, to pay them to do what we need when it's paranoid, lunatic, national security stuff. But making the market demand the right sort of security and rewarding those who do it well has got to be a decent place to start. Trying to manage cybersecurity completely devoid of the vendor's commercial contexts doesn't seem sensible to me. Okay. He says, I know I've been banging on about this forever, but the last few years have shown how important the mantra is. Details matter. Deep down, we all know how much details matter, but we also all seem to find it easy to fall back to generalizations and hyperbole. It is critical that we get into the detail of things, whether deeply technical things that only 3 people on the planet care about, or discussions of policy that will affect everyone in the country. If we don't, we eventually make a catastrophic error that will have real-world consequences. So here it feels to me like, this is the previous head of the NCSC who's talking about, bureaucracy has a problem because it has a problem dealing with things that are detailed. He says, while it's not pure cybersecurity, the somewhat polarized discussions about child safety and end-to-end encryption typify this problem for me, but I see it in many places. I honestly think that getting into the real detail of hard problems is what helps us see pathways to solutions. As I said at the start, there's a long way to go for cybersecurity and a lot of hard problems still to solve. Details are your friend. And actually, he then goes on at some length about what he calls his grand unified theory of cyber, where everything is known about everything, about networks and software and functions and vulnerabilities and interactions, and where everything can be interconnected and graphed to drive decisions. I didn't include it here because it's very long and because the creation of artificial sentience will likely occur first. So anyway, I thought that sharing his recitation of the fundamental problems was useful. And even though I know they will all have sounded familiar to anyone who follows the podcast, if nothing else, we do appear to be moving toward a general consensus of the problems. Although, yes, we can look back over the past 50 years since the identification of the first memory-based vulnerability and bemoan the fact that we also suffered from another one just yesterday. 50 years ago, we didn't have any grasp of the problems we were going to be facing. Today, at least we have that. So it's a start.
Yeah.
Even if all we can talk about is blue sky new operating systems that don't actually do anything.
I do feel like we're making some progress. I know that the landscape is littered with security problems, but I feel like we're understanding what the issues are a little bit better. Yeah.
Yeah, and it has to be that bringing pressure to companies that need it is where the solution lies.
Well, you do that very well as explain and elucidate what's going on in this world around us. Steve Gibson, his website, grc.com, the Gibson Research Corporation. That's where you'll find SpinRite, the world's best mass storage, recovery, and maintenance utility. 6.0 is the current version. 6.1 is in process, as you hear, very close. If you buy 6.0 now, fear not, you will get a free upgrade to 6.1. So you're not going to miss out. Plus, you get to participate in the development as we get closer. He also has copies of the show there, grc.com, including 2 unique copies. He's got a 16 kilobit version for the bandwidth impaired and transcripts written by a human, Elaine Ferris. So those are great. You can search those to find what you want or read along as you listen or, use them however you like. GRC.com, lots of other free stuff there. Well worth checking out. We have 64 kilobit audio at our site, twit.tv/SN. We have a unique format, video, if you want to watch, see all the blinking lights blink. That's also at twit.tv/SN or on YouTube. There's a dedicated YouTube channel. And, of course, you can subscribe to either version of the show at the website. I'm sorry, at the website. We have links to the main big-name podcast clients, but really any podcast client, if you search for Security Now or TWiT, you should find it and be able to just press a button and subscribe to it at no charge. We do have ad-free versions of the shows, all the shows, including this one, for $2.99 a month. Or you can spend $7 a month and get all the benefits of Club TWiT, which means all the shows ad-free, the special TWiT Plus feed with lots of stuff we don't put out in public, like Hands on Windows, Hands on Macintosh, the Untitled Linux Show, Stacy's Book Club, the Giz Fizz. We also use the club to launch new shows, and we have a great Discord server, which is incredible, a wonderful place to hang out. I think that's a great deal for $7 a month. For the holidays, you can buy a year-long package for the geek you really like. And we also have corporate packages. We get a lot of corporate memberships all of a sudden, which is wonderful. It really helps us, stabilize in very uncertain economic times. Now, I know times are tough for you too, so don't worry. We will always offer free versions for those of you who can't afford it. But if you can, $7, that's all every month, and it sure helps us an awful lot. After the fact, I did mention all that. I know what I didn't mention. When we do the show, which is Tuesdays, around 1:30 Pacific, 4:30 Eastern, we are going off daylight saving time on Sunday. Yep. So our new UTC time will be 21:30 UTC. You figure out what time that is in your local jurisdiction. I don't know. It's up to you on that one. 21:30. And I mentioned that not because you could always download it at your leisure, but if you want to watch us do it live, get the very first version of this show as we're recording it, you go to live.twit.tv at that time. You'll be able to watch that. You can chat if you're watching live. That's one of the advantages of live is interactivity. The IRC is open to all at irc.twit.tv. And, of course, the Discord for you Club TWiT members. Join us next Tuesday. Election Day, Steve.
Oh, my God.
Came up on us fast. Yeah.
Boy, it's going to be interesting.
Yeah, it sure is.
Super, super interesting.
Could be the last election we ever have. Or
that'd be nice.
You could vote. Thanks, Steve. We'll see you next time on Security Now.
Thanks, buddy. Bye.
Don't miss All About Android every week. We talk about the latest news, hardware, apps, and now all the developer-y goodness happening in the Android ecosystem. I'm Jason Howell, also joined by Ron Richards, Florence Ion, and our newest co-host on the panel, Wen Tu Dao, who brings her developer chops. Really great stuff. We also invite people from all over the Android ecosystem to talk about this mobile platform we love so much. Join us every Tuesday, All About Android on twit.tv.
Security Now.